Today I'll show you how to store metadata for your NFTs on IPFS. For this example, I'll store metadata about the original 151 Pokemon. For each Pokemon, we're going to store attributes such as name, description, and image. The attributes that you need for your metadata are specified by the platform that you're going to use to display your NFTs. For example, if we're going to use OpenSea, we can head over to the OpenSea docs and then look at their metadata standards for ERC 721 to see which attributes they support. Scrolling down, we can see that OpenSea supports attributes such as image, image data, external URL, description, and name. You can store your metadata on a decentralized system like IPFS, or with a centralized provider such as Amazon's AWS. If you're using a decentralized system like IPFS, then you have to make sure that there's always at least one node out there that's able to serve your request. Pinning services like Pinata and NFT Storage help to ensure that those nodes are out there. For my demo, I'll be using NFT Storage. For my setup, I'm using Hardhat and NodeJS. I've already created accounts for NFT Storage and Metamask, and I've already downloaded metadata for the 151 Pokemon. I have a CSV file that includes the names of the Pokemon and their descriptions. In my code, I'm basically going to iterate over the CSV file. Each row of the CSV file contains one Pokemon, and for each row, I'm going to store the metadata for that Pokemon on NFT Storage. In Visual Studio Code, I have my directory set up using Hardhat, and I have my Pokemon metadata stored in this assets folder. Inside the assets, I have images of the original 151 Pokemon, including new. So for example, for number 1.png, we have Bulbasaur. For 2.png, we have Ivysaur. And for 150, we have Mewtwo. Inside the assets folder, I also have a CSV file, which contains the number, the name of the Pokemon, and the description of each Pokemon. In the scripts directory, I have an MJS file, which will store our metadata on NFT storage. This file references private keys, which I've stored in the .env file. I'm going to loop through the first 30 rows of that CSV file. And for each row, I'm going to extract the name, the description, and generate the path to the PNG file which represents that Pokemon. When I have those attributes, then I'm going to call this method called storeAsset and pass it the name of the Pokemon, its description, and the path to the picture. The storeAsset method is going to call the NFT Storage API. It's going to name each Pokemon with a prefix, blockchain Bob, and it's going to add in the description, and for the image, it's going to reference the path to the picture that's passed in. Afterwards, when the upload is complete, then the method is going to log to the console saying that the Pokemon has been stored at this URL. So now I'm going to use Node to run the script. Currently, we're processing the Pokemon, and then our console is saying that the URLs have been generated. The top URL is for Ekans, so let's open that. In our browser, we can now see the metadata for Ekans. Its name is blockchain Bob Ekans. It has a description, and it has an image. We can look up this content identifier to see the photo of Ekans. And there's Ekans. Let's also look at Raticates. So here it's called blockchain Bob Raticates. It has a description and an image. So let's look at the image of Raticates. And there's our Raticates. If I go to my NFT storage account, I can also see the files that have been uploaded to IPFS. If I search for the content identifier for Raticate, I should find it here. Control F, and there we can see is the upload for Raticate. Please let me know your feedback in the comments. In my next video, I'll demonstrate how to create NFTs for all of these Pokemon.